All right, I think that should do it. I think that should be live. So let's just try to get this lined up a little bit on the computer. All right, Mike, say hello.
Hello.
All right, there we go. So, yeah, your cards that you're looking at. So first off, let me show you the behavior so you understand what you're looking for, okay? What you're trying to get to happen. Here's your power strip, right? Just move this a little bit to make it easier. You know what I'm going to do is actually move this strip to be off of here instead of off of that back one. Would you please rotate this guy so the front panel's facing the camera? So yeah, I'm going to move this strip, right? Oop, wrong one. But actually, that's good. I need to take this one. Would you please plug this strip into that other strip right here? There we go. Then I just bought that strip, a little bit of extra space too. Okay, and then you can take that strip, and move it up on top of the SEL, which means if there are any problems or an emergency or anything, you know, it's quicker to grab at most of the time. Okay.
Is this for the teletype or something?
Yeah, that's the teletype bypass interface I was talking about. So that's what allows me to interface the SEL directly through the bus rather than through the teletype, or rather it's same bus. All right, so that'll let you easily turn on and off just from right there. Right here. It's kind of there. That ought to stay right there. There we go. All right, so let's go take a look at the behavior. And I give it a 20% chance it'll just work now, because that's the way this thing usually operates. Try to make it work the first day, doesn't do anything. All right, let me turn it on. Okay. Let me make this light indirect. Oh yeah. That's much more reasonable. Oh yeah, okay, cool. So first you want to do master clear right here, okay? Then fill out your transfer register. Okay. So one thing that is wrong. So first off, A accumulator, B accumulator, gorgeous. Perfect. Okay. So I'm going to empty those back out. What I'm going to do is instruction counter. Boom, 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 boom. Right?
So are those bulbs bad or?
Well, I'm not sure. They're warming up, so maybe not. I think those might be actual bad bits. And then if I go up to my program counter, this one is like full on stuck. And I'm really worried about like breaking it if we keep trying to pull it, because we've tried a couple times, but we do need to get that guy out. Okay. And then what we're trying to troubleshoot is, right? So you see this enter, right? So right now it's at memory address 0. I'm going to hit enter. That should be entering FF into core memory, right? It's not working. Like because if I do a display, see? It's nulls in there. So if I do this and enter and then display, it should show those repeatedly, right? So if I step through, display, step, display, step, display, it's all nulls, right? Which could be right if it were all zeros. but it's doubtful. We are stepping through, so there's a lot good, right? But not saving the memory is the problem we're trying to troubleshoot. The core is not showing up. So I think the voltages should be good to go. You know, the next thing is, right, taking a look at the schematic for the core and just kind of tracing through and seeing what we should be seeing at the edge of it is what I would do. And then just clocking it and seeing whether or not the address is even showing up at the edge of the core. That makes sense? So your core, let me rotate it.
So see, part of the problem here is that I've never actually used one of these old ancient machines. I have that Pi DP11 like you got, but I never sat down to really play with it. I got it working, but never, all the deposit, the whole interface. I'm pretty sure they're probably very similar. The problem is that's not what I've never.
Okay.
That whole interface is new to me.
Let's see.
So I'm not even sure I really fully grasp how to use the front panel.
You're all good. So you want to start on that guy and get used to it then. So that's fine. Let me back this up a little bit. So yeah, that's the core down here.
Mm-hmm.
Okay.
Yeah.
These are all your bits. So that's it.
So
these are bit slices.
Oh, bit slices for the processor.
For interfacing to the address, to the memory. You can troubleshoot there, right? As you see, here's where it all runs to your core. Let me point this even further down. Okay, so this is your core memory. This is where your schematics tell you what the signal should be for your address and voltages. And this is where you get the data back. Okay.
When you say get the data back, that's where. I mean, obviously, there's circuitry just devoted to the.
Whenever you read,
yeah, it's a destructive.
It's destructive read, so you have to read. So it's always the same cycle, whether you're reading or writing. It's the same thing,
yep.
Right? So whatever you get back, you then have to rewrite so that you end up with not a null.
Yep.
So that's all it does. That's what that is. Those are those cables. But
so
you don't have
which ones, the top or the bottom?
What?
Is it the top? Is it this or that? The cards there or the cards there? Which cards are doing
these
what?
Cards interface to the actual core memory stack, which is here. Okay. That's all high voltage. Right. None of the high voltage leaves here. This is all your RTL and TTL, 3.6 volt. Okay. So this handles your cycling, right? This handles actually doing your XY logic, your sense logic, etc.
That's all in here, is what you're saying?
In here.
Oh,
this is your core memory stack.
Yeah.
Okay, it's here and here. Okay, so if we look at the front.
So what does this do?
This is the SEL bus interface. This does like your address lines. Like I said, this is where your address gets decoded. So there's two sets, one for the lower 8K, that's what you're looking at here, and another for the upper 8K back in there. Okay, so depending on how they're strapped, specifically this card here, H6 or 6H, depending on how it's notated, right? This one's strapped for lower 8K. You can see that right there. See that? Mm-hmm. Okay. And then there's a different card that is strapped for upper 8K. Okay. So what I was going to do is actually swap in the upper 8K card to the back plane of this guy and then maybe try wiring back up the upper core. But for you right now, what I would do, okay, is work on the operational SEL and get used to its operation.
Okay.
Over there, yeah. So check out its wiring, get it fired up. It's fully operational. The last thing I was working on was getting it to read tape. So if you can get up to that point where it's powered up, that'd be great. And then we can work on getting the TEL type wired up to the bus. So let me point the camera back over at that machine over there instead. How far can I get this to go? Oh, pretty far. Can I get it up there? No, I cannot. No, that'll just have to be good enough. Okay, have fun.
So how do I use this then? Or is there a manual I can read?
There's lots of manuals.
Or just how do you use this?
The power strip's right back here.
Okay, so there's the power switch for that.
Mm-hmm.
So it's halted. So now we know what that does.
So normal operation, transfer register, right?
So the transfer register is this is just for the user interface.
Yeah, well, no, it's on the bus. It's fully on the bus. It's the transfer register. This is where you put things. It's the only place you can put things, right? And then I can transfer that into the A accumulator, the B accumulator, the instruction counter, and the program counter, right? Those are dead bulbs. I need to go repair them, right? So if I take here, let me do a master clear. If I display, right, I've got a parity error in memory address 0. I actually know what that's about. Now if I do this, enter, display, you see how it's FF, master clear, display, still FF. That's it. So memory address 0, that's my program counter, is now FF. Okay?
You're giving it a very brief thing.
You wrote all those things about paper tape and punch cards.
I know that.
Yeah,
it's
experience
with that. I just have.
There's your 16 bits.
Well, so this is what. Okay, so all right, I know what accumulators are. That's fine. So this is the current instruction that it's trying to execute.
If you hit single cycle, that's what would execute. That's what is in the instruction counter. It's not trying to execute anything. That's what's in the instruction counter. So if it were to execute instruction register. Yeah. So if it were to execute, that's what would execute.
Because that's the current instruction.
That's the next instruction that will execute, not the one that just did.
Okay, so this is the next instruction. Okay, that's important to be tough. Obviously, program doesn't really understand that. So the transfer register, this is not something that any of the machines I've ever used has a transfer register.
Yeah.
It just doesn't exist,
right,
because it doesn't have this. I assume this is basically just. I mean, the machine itself doesn't really need the transfer register.
The transfer register is on the back plane.
Just hear me out. If I understand, maybe the transfer register is there for this panel here, mostly. It's not for. I mean, the program, the transfer register could be doing absolutely nothing, and the computer will execute its
Yeah,
code
but that's
fine,
true
right?
for everything. You don't have to use the B accumulator. You don't have to use the A accumulator. It's just another register. It doesn't matter where or how.
Do instructions read and write this register?
Yes. Yeah. There's a T. There's a T instruction. Look, here's all your instructions.
Okay.
Right. So STA, STB, TAB, TBA, TEU, TOI, I believe.
So we're store A, store B, I'm guessing.
Yeah.
Transfer A to B, transfer B to A.
No. Let's get the blue book real quick. It should be right here. Where's my blue card? Is that it? No, that's for a different machine. Oh. I'm used to having everything just at my fingertips with all this stuff. No, that's the modem. We don't need that for a long time. That's what I started working on because that's what didn't work on the old one. Core memory, paper tape, TCS, DCS. This is the memory map. This is not going to have any instructions.
No, memory maps.
Well, I mean, that's just. That's not what this is. This is just a general guide that they had for the. But I don't think it's in
The repair technicians. Is that what it's for?
Okay, and then here's the Bible, but even the Bible's not going to have it because they just had that blue card at every site. So I have to go grab one of the blue cards. I have bus signals, input status, and yeah, this is all checkout. One second, I scanned it, so it's online. Let me go grab it. Well, I would also turn it back off, Mike.
Should I turn off the machine?
Yeah, just turn it back off.
Okay.
Okay, so what I'm looking for is. Oh, I can't remember where I uploaded it to, but it'll be in one of these places. One or two. SEL 810.
Yeah, where it probably is. It's probably out in the garage.
Everything. That's kind of that's a running joke.
Mm-hmm.
Oh no, that's the 840A reference.
where that red ID to USB interface is? That drive interface? Oh, there it is.
Yeah.
Right there.
Oh, here it is. Programmer's reference card.
There
There you go, Mike.
That sounds good.
Okay, command external unit, command compare memory and A 3 ways. Transfer B sign to carry and set. Left shift A and B. Load control switches in A. So this is one of the way LCS. Set T register when you flip it the other way is also the control switches. It's both. It's kind of complicated. Here, yeah. And those are transfer B accumulator to protect register, hardware index register, transfer A to B, right?
So TAB is transfer A to B.
Mm-hmm.
Okay. Okay, that I expected.
Yeah, and then you can transfer the A accumulator to the B to the hardware index register.
Okay.
And then VBR, which is a whole different ball of wax. And that is it. And then, yeah, all of your, you use them for, you see these SS's? Those refer to, this is where it gets weird. That refers to setting your, your software switches. So I'll show you how that works. This puts it in software control switch. Okay. So like this would be, if I were running the assembler, I would, this is software switch 15 up.
Okay, so this is like sense switches on the IBM.
Right.
Okay.
But if I'm using the transfer register,
Then you, okay.
momentary down.
So momentary down to load of one in. You would have to use master clear to clear it though.
And then you would set your sense switches. And, well, first, the whole sequence would be enter everything in. So the best thing for you to do right now, honestly, would probably be to enter your bootstrap. Mm-hmm. Okay.
Or maybe even there or something.
Oh, yeah, sure. Do that. Yeah. Load this in and get it to execute. That should execute perfectly. That should loop through memory. Okay. And clear all the memory. And then we can make sure everything's happy. Okay.
So Eric, do you know much about this?
Not too much.
It's like this could go up and hold, or it could be pushed down.
Right.
What's the difference?
That I don't know. It could be the same thing, just for one fixed and one intermittent. But I'm not sure.
Yeah, that could be.
You don't need to push any of them up for any purpose that you're doing right now.
So what's the difference between pushing down and pushing up? Where it's
Pushing down puts it in the transfer register. Pushing up makes it so that it'll be detected as a load control switch. But you don't need to push anything up right now.
By any chance, is there a manual for this front panel?
What? Yeah, there's tons of them right there. Which one do you want?
For the front panel, using just the front panel. Is there like a
I can go
manual?
grab you the SEL 810A manual, yeah. But it's easier just to probably watch one of my videos realistically.
The manuals are good. I like manuals.
Okay. Well, the 1960s manuals are very different. The terminology you're going to have to learn. That's what took me a year, was learning the terminology.
Mike, you okay with that? I've read old historic manuals before.
Let me see, guys. This is not the one you want.
I've read some old manuals. I might be okay with that.
the edge. And then I found my teletype repair box. So that's exciting. Teletype repair box. Box of little tooly loolies. There's people here? Hi. Oh, I guess. Oh, there was a thumbs up. Well, thank you, whoever thumbs this up. I found my ASR 33 repair tools. So I'm going to go unbox that. Did you see my ASR 33 repair 32Y repair tools box? Oh, I did that. Sorry. There you go. It's a pretty one too. I like that blue. Mm-hmm. See that? Ooh, that's greasy. Ooh, look at that.
Cheat sheet.
Uh-huh. What's this? Look at this. Ooh. Ooh, wow. Those like little specialized feeler gauges.
Something like that.
That's a whole set of specialized feeler gauges.
Wow.
And tools, yeah. Mm-hmm. Oh, wow. That's neat. Wow, that is very bespoke. What is this? A big thing of grease. Of course. Whatever the heck that is. What? Oh, that's a greaser. That's a grease pen.
Oh, okay.
Mm-hmm. Is that a wire wrap tool? You're a pretty lady.
Oh, yeah.
Fuses, so many fuses. Oh my God. Cool. Well, I need to put some different tools in there. That's awesome. we go. Look how pretty that little toolbox is. Little ASR Model 33 TTY repair kit. Love it. Here, I'll put it over here. You get the manual you want?
Not sure. It says it's all programming manuals. I'm looking through the diagnostic. See,
I mean, I can send you the link to the right one. He might have only sent Al the ones that Al was missing.
that could be.
Oh, I need to go put this in the box with the rest of the stuff.
Do you need help with anything?
No.
Okay.
If you're just looking for something to do, I've got a whole list of things, man.
Okay. I'm just thinking probably what I'm going to need to do is just go on to archive that, or not archive, BitSavers, yes, Al Kowalski's. And then just find the documentation and just start doing a lot of reading and try to figure out, and then come over here and play with those sheets. It's like, oh, yeah, this is what I was reading. Yeah, it's that kind of a thing.
Okay, so I can't just give you something to do with the SEL that's hands-on.
The problem is, I mean, if you gave me like a simple test, like you were telling me, you gave me that chart, and it's like, just you showed me how to find it, and it's like, oh yeah, I know how to use a multimeter, so that's easy.
Well, that's you could do that right now, right?
When we did that.
No, with the other machine, the working machine, right?
Oh, do you want to check that one too?
Yeah, just check that one's voltages.
All right.
Do exactly that with this one. Check all its voltages out real good.
Oh, all right.
Um,
I don't know.
yeah, go ahead. Have fun. Yeah, just check it out. Enter this for when you're ready. When you've got all the voltages checked out, let me know. And I'll show you how to enter this. Okay. Now remember, that bad boy's energized. Just flip the emergency power and it'll fire right up.
Yep.
I got some more trash coming out here. Cool. All right, there we go. Okay, let me put this away. Oh wow, a lot more open looking.
So it's just the same chart again. Same chart as before.
Yeah, same, should be exactly the same.
Okay.
Same exact voltages.
Okay. A little bit different conversation. Three. Two. Okay. Just check the voltages.
You want to go to lunch soon?
Yeah, probably.
Mike, you like Mexican food?
Yeah, sometimes.
You like Chinese food better?
No.
You like any food?
It just depends on how spicy the Mexican food is.
It's not.
If it's
It's
not,
white. It's white people Mexican.
oh, okay, then that's probably fine.
Yeah. Okay. Let's try this. What's wrong?
I think you should try it.
Oh, that one?
It might be.
Is it spinning? Is it
It's
even
not
trying?
spinning, and I haven't had luck with getting it running. And now when I try this power supply, the light blinks when I plug it in, so it's overloading somehow.
That's better. All right, let's see. Do you want me to adjust them down? They're like 4 volts instead of 4.6.
Yeah, get them at 3.6. The 3.6 lines should be pretty on the money.
That's the amplifier. All right, so this is very, very fulfilling. The moment I put the tool in to adjust the pot, it started to turn it. It dropped down to 0.6 and it's only 0.6.
Yeah, turn it back off. Adjust the pop back up, turn it back on.
I mean, I've tried turning it full.
No, don't do don't do that. Don't turn it all the way. Don't go back and forth. You're doing micro adjustments all the
Yeah,
time.
but it's stuck at.
Turn it off,
Well,
turn it back
and
up,
put it back to where it was, and then
turn it back on, and then get a fresh measurement. Right. Is it still at 0.6?
Yep.
Okay, then yeah, shut it back down. We're gonna have to pull that power supply and troubleshoot it. You ever worked on a linear power supply?
I know the basic theory behind it. I mean, I wouldn't be surprised if the pot is just dirty.
Yeah, but it wouldn't jump down to 0.6.
Yeah,
Yeah.
I mean, that doesn't make much sense, but don't.
Well, I'm not surprised. I was expecting to have to pull one of those power supplies. I was surprised they all just worked. So start eyeing up how you remove them. It's really hard. Don't undo anything yet, obviously. Those caps don't really go bad. That's what's crazy. They're so huge they don't go bad. It's weird. Yeah, show Eric which voltage it was that was unhappy.
Because these two right here is this is supposed to be, well, this is labeled 3 to 5, but the manual said 3.6. It was at 4. So I just put the little screwdriver he gave me before, put it in that right there, made the turn backwards just a little bit, went down to 6, never did anything else. I really suspect that it's just a dirty pot.
I have the pot deoxit.
Do you have it in the house or on your car?
In my car.
Cool. Well, let's grab it when we get back from food.
Okay.
Mike, you want to come?
Yeah, I can come.
That's annoying. Why? I think they made it that sound so that, you know, old people could hear it. Had to be nice and loud.
Yeah. It also helps in a noisy environment.
I think this power supply comes out from the other side. I think the fasteners are probably in the back.
I think there's a fucking shorted tantalum on this board.
Tantalum? Really?
Yeah.
What'd you say, Mike?
I just was suspecting that to get the power supply out, I think we got to do it from the rear. I think the fasteners that hold, because it's basically one big assembly with a lot of stuff screwed to the back of this plane.
No, you take the whole thing out.
Yeah, so
Yeah.
I think those fasteners are in the back. We'd have to
I don't remember them being in the back. That they were all in the front. I thought, but maybe I don't. It's been a while since I took one of those out.
Yeah, I can feel it. They're in the back. Definitely.
That's gonna be fun.
Yeah, it's like working on a car. I've seen much worse on cars. difficult is when the captured nut comes loose on the hidden side that you cannot possibly get at, and it's now just spinning, and so you have to get your Dremel and cut off the head of the bolt. That's when you're hard. So do you have a way of figuring out which one?
Oh, I just measured across the cap, it's 7 ohms. So, and then when you plug it in, with this one, the light blinks. So that's telling me the power supply shutting down. So I'm pretty much assuming that this cap is bad.
So you know which one?
Yeah.
Okay.
Yeah, I don't know if there, I don't know that there is another one on here.
Oh, there's just one.
It's just by the power supply. Looks like there might be a couple more inside, but yeah, this might be a loss for today. I can do other things. I have some other things.
Awesome. All right, just found another bug. Oh, it's just forever and ever and ever with this shit. One after another after another. Oh, look at that. All beautiful and green, except for that red, but that's expected. Yeah.
Okay.
Including the
Mm-hmm.
audit trail, registry key validation, the whole nine. I'll be happy. Just got to make it so it can, yeah, let's roll before, because I will not stop,
Mm-hmm.
I will not stop. I'm gonna ask my wife what she wants to eat. Tacos. I love tacos. All right, let me stop the stream here. We'll be back later.